नमस्कार, आप सभी का स्वागत है एनसीईआरटी के लाइव इंटरैक्टिव सेशन में। मैं हूं सिमरन सिंह और आप सभी दर्शक हमारे साथ जुड़े हैं ई विद्या के चैनल नंबर 9 से 12 के जरिए। इसके अलावा आप हमारे तमाम कार्यक्रम देख सकते हैं हमारे यूट्यूब चैनल पर। जैसा कि आप सभी जानते हैं, हमारा यूट्यूब चैनल है NCERT Official. And once again a very warm welcome to all our viewers in our special series that is Listening to Learn. सुने और सीखें। इसी के साथ आपको बता देते हैं कि आज इस श्रृंखला यानी इस वेबिनार सीरीज का ये 64वां संस्करण है। दिस इज द 64th एपिसोड वेयर वी हैव डिस्कस्ड सो मेनी डिफरेंट एरियाज राइट फ्रॉम अर्थ टिल स्काई. A lot has been covered and a lot we are still going to cover. And the topic for today's discussion is really very interesting. It's all about importance of aviation meteorology. So meteorology and its significance can be understood from a very simple thing. Like right before stepping outside your home, you check the weather update so that you need to carry an umbrella or not. That is significant for us, right? So you can imagine the importance and the significance of meteorology when it comes to the aviation sector, because weather forecasts, they can have far-reaching consequences. So it's important to understand that. Let me also apprise you that these sessions are brought to you by Department of Education in Science and Mathematics from NCERT, New Delhi. Viewers, in this live session, if you have any of the queries, then feel free to connect with us through the contact number flashing on your screens. जैसा कि आप सभी देख सकते हैं, आपकी स्क्रीन पर हमारा कॉन्टैक्ट नंबर फ्लैश हो रहा है, जिसके ज़रिए आप हमारे साथ संपर्क साध सकते हैं. It is 8800440559. Also, we have few mail IDs where you can write to us, you can reach out to us. One of them, I am saying it here, it's dth.class12@ciet.nic.in. और हमेशा की तरह हमारे साथ हमारे खास मेहमान तो जुड़ते ही हैं, पर सबसे पहले आपका परिचय करा देते हैं द ब्रेन बिहाइंड दिस प्रोग्राम. ही इज़ डॉक्टर गगन गुप्ता फ्रॉम DSM NCERT. नमस्कार सर.
नमस्ते सिमरन जी.
And sir, as we are approaching and we have reached to the 64th episode of our special series. So sir, I'll also request you to introduce the program, the topic and our special guest with all our viewers.
Sure. Thank you सिमरन जी. Today सादर प्रणाम दोस्तों. अगस्त 2021 में NHRC नेशनल ह्यूमन राइट कमीशन एंड काउंसिल ऑफ साइंटिफिक एंड इंडस्ट्रियल रिसर्च के कोलैबोरेशन से स्टार्ट हुआ ये प्रोग्राम आज अपने 64वें पड़ाव पर है. इस बीच में हमने न्यूट्रिशन, न्यूक्लियर फिजन, न्यूक्लियर फिशन, न्यूक्लियर प्रॉपर्टीज़, बैटरीज, इंडियन प्लानिटरी मिशन, इंडियन स्पेस मिशंस, इसरोस प्रोग्राम्स एट्सेट्रा हमने यहाँ पर लिए हैं. बीच में आप याद कीजिए, आज से 2 हफ्ते पहले, 1 महीना पहले 29 सितंबर को मेरे साथ जुड़े थे एयरफोर्स ऑफिसर एयर कमांडोर अश्विंदर सिंह. He is a great friend of ourselves. He is a friend indeed. Ashminder Singh, I am sure that you are listening us. Today I have another Air Force officer today with me. This is Dr. Rajiv Kumar Mahajan. He has been of diverse capacities, diverse capabilities. I will be discussing a little about him. Friends, in between your today's session, Aviation Meteorology, this has been there in our list for a long, and I am thankful to my friend Dr. Rajiv Mahajan who has agreed to do this session on a rather very short notice. Dr. Mahajan, this program, this schedule, this session was wanted by us for a long. Children of this country were asking, and teachers as well were asking us to have a session on this. We are it so happened that in between we got some other sessions, etc., and we are very lucky to have you with us today. Ultimately, my dear friends, we are able to do your demand. Please asking us, keep on asking us, keep on suggesting us your new topics, etc. Today we have another officer from Indian Air Force and the Science and Engineering Research Board, Government of India. We are going to have another officer from Indian Army soon in the month of December, and then soon in the month of February we are going to have an officer from Indian Navy too. In between, we are going to have sessions on operational mechanisms in the Indian space, on Gaganyaan, etc. So keep on watching us. Please keep on giving your suggestions. Your suggestions are very important, very useful for all of us, and we definitely assure you to cover your suggestions. All the sessions, all the 63 sessions which have taken place so far can be seen on the link which is being flashed at this moment on your TV screens. And today's session will also be uploaded on this link shortly after this today's session. So, once again I welcome Dr. Rajiv Mahajan, our great friend. So, friends, let me introduce, आपकी मुलाकात कराऊं डॉक्टर राजीव महाजन से. डॉक्टर राजीव महाजन a doctorate in meteorology and masters in 4 subjects, namely mathematics, meteorology, defense strategy and business administration. You can understand the diversity in Dr. Mahajan. He has had a decorated career of close to nearly 4 decades in 6 organizations, including the United Nations, the Indian Air Force, India Meteorological Department, Ministry of Earth Sciences, Ministry of Defence and Science and Engineering Research Board of the Ministry of Science and Technology, New Delhi. His remarkable contributions have been awarded by the Indian Air Force and the United Nations. He is an international intergovernmental expert member for both the technical committees of the World Meteorological Organization at the United Nations as well as the Aircraft Accident Investigation Bureau of India. Dr. Mahajan has been a council member for recommending the best corporate brands in the country at Brand in Sync listings, popularly called BRICIL. He has also been the chairman of the board of studies of Bharatiya University, Coimbatore. Dr. Rajiv is a blogger, a published poet and also a dedicated marathoner and enjoys hot yoga and is a professional cyclist too. He is a young man. He enjoys getting connected to acquaintances and growing his professional network. So, once again welcome Dr. Mahajan to our platform. We are indebted and we thank Ministry of Science and Technology and Indian Air Force for having collaboration for today's program too. We look forward to having more collaborations with Ministry of Defence, Ministry of Science and Technology, etc., etc. in our due course of time. So, Dr. Mahajan, it is all yours, please.
Thank you. Can we have the screen, please? Good morning, ladies and gentlemen. Unlike many other applied sciences, including medical sciences, the science of meteorology, in other words, atmospheric sciences, is relatively too young, as much as about 450 years old only, with its early evidences close to perhaps 1670. However, this field particularly has grown exponentially during only last 50 years, driven by the need of more and more accurate weather forecasting. To be precise, today it has evolved from an art that purely relied on experience and intuition, which I often refer as meteorological sense, into a science, a full-fledged science that relies on none other than numerical weather prediction models itself. They are based on conservation of mass, momentum and energy, but obviously with lot of assumptions. When I say lot of assumptions, that's the reason of the gap when it comes to the accurate weather forecasting. Weather forecasting, ladies and gentlemen, can never be accurate 100% today, yesterday, and it would never be actually. The reason is that it would keep pushing the limits of the motivation of the science per se, as well as the infrastructure when it comes to satellites, when it comes to radars, etc. But when it comes to 100%, it is impossible to achieve for any country in the world actually. I am from an era who entered into this science way back in 1987, where I more relied on meteorological science, and I called it as a human radar. Why? Because those times in Air Force there were hardly any kind of modern gadgets. There were only 3 stations which used to receive even satellite imageries out of total of 52 flying stations where this kind of activity used to take place, to an era where I graduated another 15 years perhaps plus later, somewhere in 2004, when I started teaching the new subject of numerical weather prediction in Air Force Administrative College, the meteorological faculty, to my young fellows. Coming to this talk per se, this aviation and meteorology, they seems to be 2 different distinct sciences, but interestingly both grew hand in hand. Rather, it is meteorology always that pushed the limits of aviation industry. And when I say so, it was always basically for the need of the safety of aircraft in crucial stages, whether it is takeoff, climb out, cruise, the landing phase, and so on. Therefore, the importance of this premier subject like aviation meteorology to be brought to august audience like you at this platform cannot be underscored. This being my first dedicated talk to the school students on the subject per se, I made certain assumptions, and the first assumption which came to my mind was you all enjoy watching sky and the changes in the sky. You have curiosity behind these little changes which are happening on day-to-day basis, time to time basis, and finally you have some questions as to how really weather works, how the aviation industry per se works, and also importantly how aviation and meteorology are related as a subject actually. So I start with the first slide as the quote itself, when it says, first profession of mine was meteorology, but I couldn't cope up with uncertainties associated with it and had to switch to physics. Any wild guesses? Okay, let me perhaps make it simple for you. It was none other than Albert Einstein. Imagine a person of his aura stature, if we couldn't cope up with the uncertainties associated with subject, then how difficult it is a subject actually. When it comes to Newtonian physics, the classical physics can be used to describe the state of the atmosphere, namely air motions that obey the Newton's law of dynamics, heat that satisfies the laws of thermodynamics, and air mass and moisture that are conserved, as I said earlier also. And meteorology, ladies and gentlemen, is the study of fluid mechanics, physics, and chemistry of the atmosphere. When applied to a fluid such as air, these physical processes describe the fluid mechanics per se. The atmosphere is a complex fluid system, a system that generates the chaotic motions, what we call as weather. So there are two terms which I am coining, complexity and chaos, and these are the two terms which are going to play an important role in understanding your perception about aviation meteorology. This complexity per se is caused by interactions between many physical processes acting on different locations, different times, and different time scales per se. For example, the time differences, I stand corrected, the temperature differences across the locations create pressure differences. In turn, they drive winds. Winds moves the water vapor about to the places, and when water vapor condenses, it releases the heat, what you call as latent heat, altering again the temperature differences. So such is the feedback happening in the atmosphere, and importantly, contrary to the popular perception, these feedbacks are non-linear in nature, and this is how they create the word complexity. But the result of the chaos and complexity is a fascinating area of weather phenomena which you always observe on day-to-day basis, that are inspiring in their beauty and power as they are challenged importantly to depict as well describe how we dress from day to day basis, what should I wear today, where we live, how we travel, what we can grow today as far as the agriculture products are concerned, and sometimes also how do we feel. That means my emotions, your emotions, they are also related to the weather per se. So what I am going to do next few minutes is going to take you on a weather flight where I am going to initially start distinguishing between what is weather and climate, though they seems to be synonymous terms actually. I'll get into the basics of aviation meteorology. I will get into the weather and its impact on flight per se when it comes to aviation meteorology. The meteorological parameters, once again the basics. What exactly are the prime meteorological parameters that define the subject? Aviation weather hazards, I am going to touch upon particularly thunderstorms, and before I summarize, I am going to slightly make an attempt to improve the perceptions further, not only on the subject but about the entire ambit actually. How do I put it? The weather per se, you might have heard about this term weather and climate, but when it comes to the weather, this is nothing but conditions of a specific location and moment. So that means what I'm talking about is space and time. That means I'm talking about instant. That means at 1015 hours 39 seconds, what is the weather at NCRT building and precisely CIET building, what temperature, what pressure, what density, etc., etc. That exactly is known as weather actually. And it is expressed according to the 7 elements, prime elements, the air temperature, that is the degree of hotness or coldness, the air pressure, weight of air above an area, wind, that is horizontal movement of air, humidity, measure of water vapor in the air itself, and clouds, mass of tiny water droplets and ice crystals that are hanging in the atmospheres that you observe as sometimes clouds and even fog. Both are same. One is on the ground, one is in the air. Precipitation, any form of water which is reaching ground, rain, drizzle, showers, thunder showers, etc. And visibility is the greatest distance one can see. And when I say so, it's not the horizontal visibility per se, it is the slant visibility, it is the vertical visibility. Ladies and gentlemen, are you even having given a thought over it that all of these elements can be perceived or felt, all of them through our sensory organs? Isn't it interesting? Now I come to climate. How do climate is different than weather? Climate is nothing but the conditions of the same atmosphere, what we call as weather, over many years. Same weather element, the same 7 elements are also described to use the climate. The only difference is when it comes to climate per se or the climate data per se, we generally depend upon minimum of 30 years or more of averages and extremes, that is recorded high or low, that is maximum temperature, minimum temperature, and so on. Highest or lowest value of recorded for a variable, and variables are those 7 variables which I talked about on the previous slide. One particular perception which I thought I was clear on this slide, is it that only 30 years or more of data can only define the climate? No. It depends upon our constraints at times. Sometimes even when we are building up aerodrome, for example, say at Sholapur, and we have only data for last 15 years to build up our understanding about the aerodrome, how we are going to design that, it is those 15 years of data which is going to constitute the climate per se. So as I said earlier, meteorology is the study of atmosphere and weather processes that occur in it, and the behavior atmosphere that is capable of being analyzed and understood in terms of basic laws of physics. And when it comes to the meteorology, the 3 fields of the physics that actually defines are very closely related to this are thermodynamics, radiation, and hydrology. But out of these 3 subjects also, thermodynamics plays the most important role. Thermodynamics, as you are all aware, is the study of transformation of heat into other forms of energy and vice versa. As the water occurs in the atmosphere in the various forms, that is solid, liquid, and gas, all the 3 forms, these transformations, ladies and gentlemen, often occurs whenever water changes its state from solid to liquid, liquid to gas, and gas to solid once again. And these arise as a result of release or absorption of latent heat, and that is on account of evaporation, on account of condensation, on account of sublimation, and on account of 4th process. Does it sound well? I leave it to you as a question mark. Aviation meteorology per se deals with the impact of weather on flying and air traffic management. Aviation meteorology is also mainly confined to study of atmospheric conditions which have direct or indirect impact on aviation, but most importantly, it is to forecast these conditions. We'll learn about it more in next few slides. Before I go to the aviation meteorology per se, I thought, let me educate people. You are all educated, well educated. Google is there, search engines are there to know, but I thought I must put the basic into form. When it comes to the aircraft, is a vehicle. It is able to fly by being supported by what? Using air using aerodynamics. An aircraft counters the force of gravity by what is known as static lift, as we see in the balloons, or dynamic lift when it comes to the airfoils. Does it mean the rockets and missiles are also aircraft? The answer is no. Why? Because they don't use the principle of aerodynamics. They use the principle of what is known as rocket thrust per se. The classification of aircraft, that you can perhaps divide them into three parts: lighter than air aerostats and heavier than air aerodynes. There could be fixed wing aircraft, that could be fighter aircraft, as well transport commercial aircraft, which we generally fly to go from one place to other place, and rotorcraft, the helicopters actually, which are having different principles of flying when it comes to aerodynamics per se. Now coming to the forces of flight, actually, this is I thought is going to be really important for you to understand. Everything has a weight on Earth due to the force of gravity. What you need to do when it comes to the flying per se, something in opposite direction to fly the aircraft. The weight decides how strong you need this push or how strong you need this lift. So when it comes to the kite per se, there is hardly any lift required, very little lift. But when it comes to jumbo jet, you need a lot of lift to required to put this aircraft into the air actually. Drag is a force that tries to slow down the objects, as we are all aware, and actually depends upon the medium. First of all, whether water versus air, shape of the surface, that means number 2, that means round surfaces or flat surfaces, and lastly also narrower surfaces or the wider surfaces. That is how the shapes are made. Aerodynamics, not only in the aircraft but also in the cars, motorcycles, any mode of conveyance where drag needs to be countered by the thrust per se. So thrust is opposite to drag. These forces make an object move up and down and faster or slower. How much of each force matters or changes exactly depends upon how the object moves through the medium of air per se. Now let me give you a basic understanding of all the meteorological parameters when it comes to the aviation per se. First of all, comes to your mind or anybody's mind is the temperature. Temperature is nothing but related to amount of energy. Energy is absorbed or released in the process which I mentioned earlier, and there is something known as diurnal temperature range. That means the difference between maximum and minimum temperature, you must know. And you must also know there is something known as standard temperature. What is standard temperature? Standard temperature is temperature at which the whole international standard atmosphere has been calibrated actually. Aircraft performance charts are actually governed by the international standard atmosphere. There is something known as standard lapse rate. When I say lapse rate, that means reduction of temperature with respect to height as we go up in the atmosphere. Is it standard? Yes. The standard is 6.5 degrees Celsius per kilometer, but does the actual environment behave like that? The answer is no. It can vary from as much as 5 degrees Celsius, which what we call as saturated adiabatic lapse rate, and to about 9.8 degrees Celsius per kilometer when it comes to dry adiabatic lapse rate. That means in case the air which we are talking about is dry or moist. Coming to the pressure, atmosphere exert pressure. Do we experience it? The theory and the experiment both confirms we do experience it actually, okay, and it is independent of the orientation of the surface area. How do we experience it? Anything which comes to your mind? When we go up in the sky in the aircraft, when we are coming down, if you remember, when we start descending after a cruise, when our destination is about to arrive, from lower pressure area, when we are coming to once again higher pressure area, what happens to our eardrums? They start paining. Particularly the children have a lot of issues actually. So this exactly is how we experience pressure per se. What is this exactly? There is nothing but sum of air molecules of about point. Pressure decreases, all we know, with altitude. Similarly, to temperature there is a standard pressure, what is known as 13.25 hectopascal at mean sea level. There are constant pressure surfaces which are followed by the aircraft to fly, and pressure varies not only with height, from location, one location to other location, in horizontal also. Moisture, when it comes to say plays a very important role. If you want to call atmosphere as a heat engine per se, then heat is the energy in this engine and moisture is the fuel that is provided to this heat engine. We all know water is present in the atmosphere in ice, water or water vapor form, and it is measured by relative humidity, which is nothing but ratio of mixing ratio to saturation mixing ratio. And what is mixing ratio? Mixing ratio is nothing but mass of your water vapor to the mass of dry air per se. Dew point, what is a dew point? Dew point is a point at which the air should be cooled to become saturated first and then become condensed. The classical example of dew point is the winter season which is approaching, when your ground temperature comes to a certain critical value, when automatically you don't need any blessings, the air starts getting cooled, condensed, and it takes the shape of haze, mist and fog. I have another question for you. The way things are, the water samples have more or less RH. Which one, warmer or colder? I leave it to your judgment, through Google search, and this is a very important question I'm asking. And dew point, I already described: melting, freezing, evaporation, condensation. You remember I questioned you that which is the fourth process. So here's the answer. Melting is the fourth process. I have another question to you now. Density per se, which weighs lesser? What is the perception, dry air or moist air? I'm sure most of you will jump to the gun. Obviously, sir, the dry air. But the answer is, to your disbelief, the moist air. Why? We all know the air is actually composed of what? Mainly nitrogen and what? Argon. But when it comes to other gases, actually, right? Nitrogen, oxygen, the main components, and argon, a bit. But there are other gases like carbon dioxide. There is a water also present in the atmosphere. There is a water vapor. And when you come to the atomic weight of H and O, that is H2O, this comes to only how much? 18, right? In comparison to the nitrogen and the oxygen molecules, which are of the value of 28 and 32 respectively. Which is lighter? Leave it to your judgment. Density varies in the atmosphere. Density and pressure, density and temperature, and density and moisture are interrelated. You would like to know about effects of air density? You will be surprised. Most aircraft accidents occur during the takeoff and landing phase of the flight, courtesy this density per se as a subject actually. Can you believe density at higher altitude runways, like where I was posted once upon a time in Ladakh, is almost 70% of what is available at mean sea level. Reduction of almost 30 to 35% at times, and this reduction keeps on scaling when the temperatures are very high. That means during summer times, and that too in the midday actually. So the runways at high altitudes are designed in a manner where they have extended range, because aircraft needs to get uplifted in the air in those environments also. Collisions with obstacles during climb out, runway over and on landings, all are interrelated to air density per se. So the main performance factor is the air density. Aircraft all of weight depends on air density. Now I take you to impact of weather on aviation. Most of the weather occurs below 4.5 kilometer. Aircraft generally cruise at an altitude of 9 kilometer, where you hardly have any significant weather, and most of us where we are on the ground are generally in the envelope of weather. Whether the weather is occurring, the active weather is occurring or not, in that case is also we are all engulfed in the gases, isn't it so? Weather is of utmost consideration for all pilots when planning a commercial flight or tactical sortie. What? Yes. How? because whether it is takeoff, whether it is climb bound, whether it is approach, landing, cruise, destination airfields, the alternate airfields, in case he has to land at those airfields, if the weather goes bad, the weather is going to be of really importance. And it needs to be, importantly, constantly monitored by even a seasoned aviation meteorologist, a meteorologist who feels he's the hot rod weather forecaster. He also needs to be monitoring this to not only forecast per se, but continue monitoring this weather during his duty hours like a chokidar. You remember? PM, Honorable PM says, I am the chokidar of this country. So similarly, the gentleman needs to be on toes, minute to minute, monitoring of the weather. Why? Because most of the meteorological situations, whether we like it or not, relate to small scale in time when it comes to aviation per se. And they do not have a clear-cut black and white answer. Instead, what is available to a meteorologist or the aviation meteorologist per se is merely a variation on the probability scale, that is various shades of gray ranging from white to black that an aviation meteorologist interprets and calls it as an occurrence of weather or non-occurrence of weather. That means he focused it so for the issue of weather warnings, gale warnings and cautionary meteo reports. Effects of atmosphere when it comes to weather on aviation. Atmospheric conditions affect flying operations. Even parked moved aircraft can also be affected. I remember my first posting in Agra when one of the aircraft just got moved by a few inches, resulting into a major accident in Air Force Station Agra because of the winds of the order of 85 knots, roughly about 150 km per hour on ground. Designing airframe, aero engines, and as I said earlier also, the aerodromes per se. So overall effects of weather on aviation is degradation of safety, degradation of comfort, degradation of efficiency and economy of operation. When it comes to economy of operation, are you even aware in this country itself there is an airline which has its own meteorological element over and above the India Meteorological Department which provides the services. Own designated meteorological element which gives the customized services, and that airline is none other than Indigo. Wonderful. So when it comes to safety and comfort, weather is a strong factor in a large number of aircraft accidents. Rough flights are usually caused by atmospheric turbulence even under clear weather conditions. I'm sure you must have observed during at times you're flying, there's no weather around, you can't see even clouds, and suddenly there is aircraft shaking and there's a warning from the captain of the aircraft or the co-pilot of the aircraft, please be seated, belts to be on, and no movement at all during that phase. So I'm talking about event turbulence during that phase. Schedule keeping, bad weather adversely affects operational readiness of runways and other airport facilities as well as that of aircraft, resulting in flight delays, and one delay leads to the cascading effect on other flights too. Lastly, all this results into the efficiency being reduced. Factors such as heavy rain, fog and heavy snow render entire airports or individual runways non-operational for significant lengths of time. And if there is a delay, if there is a pocket of delay for about say 5 hours on a particular runway, you can imagine what kind of chaos can happen subsequently. There is an old saying, every cloud has a silver lining. In flying, we say every cloud has a hidden lining. My perception when I joined the Indian Air Force as an aviation meteorologist, completely changed about weather. Anything which was thundercloud in the horizon was appearing very nice before 1987, but it suddenly became a monster actually, right? The dark clouds. That means a signal of bad weather. What appears beautiful when you are far away from the danger can be fatal if you enter into such clouds. Not so recent pointers. Air France 447 crash in Atlantic Ocean. Let me go through it. Scheduled commercial flight from Brazil to France on 1st June 09 crashed into the Atlantic Ocean, killing all 216 passengers and 12 crew members. The meteorological analysis is flight path showed a mesoscale convective system, something like a storm, a tropical storm. Not exactly, but something like. extending to an altitude of 15 kilometers above the Atlantic Ocean before flight 447 disappeared. When I say 15 kilometers, generally the cruising level is what? 9 kilometers or so. And generally what is the ceiling of these aircraft are? Close to about 12 kilometers or so. Aircraft's final 12 minutes could have been spent flying through significant turbulence and thunderstorm activity for about a stretch of 121 kilometers, where aircraft couldn't go left, right, up or down, had no option but to continue flying in that kind of mercy conditions, was coping with a series of storms, not just one. So, ladies and gentlemen, several fatal accidents involving fighters, transports and helicopters have perished in bad weather as far as the last 15 to 20 years is concerned. The causes are inadequate training, theoretical knowledge on weather, experience of pilot in adverse conditions. Aviation weather world has been rocked in by the weather phenomena and makes one wonder whether we really understand how to deal with nature. Are we talking about knowledge? This allows all of us to make safe and intelligent decisions, but this is only half safety equation. One must observe that safe does not mean absolutely risk-free. I quote Sun Tzu, know yourself, know your enemy, your victory will never be endangered. Know the ground, know the weather, your victory will then be total. That means even in air warfare, the ground warfare, any kind of warfare. Example, in June 1812, Napoleon invaded Russia with 5 lakh troops, left off later with lesser than 10,000 surviving troops because he couldn't estimate, forecast what is going to happen when they are going to enter in the Russian winter and cold. The not so old incidents, weather and Gulf War, coalition forces encountered severe thunderstorms on 19 and 26 March 03. USA openly admitted that there was a failure, fiasco. No matter how perfectly planned, the operation could be seriously affected if weather changes to any marked degree. Now I will touch upon some of the aviation weather hazards. The time is very limited, so what I'm going to do, I'm going to mainly concentrate upon the monster, the aviation weather hazard, that is known as thunderstorm per se. And you know why? Because thunderstorm per se is not just one aviation weather hazard. It is a subset of many aviation weather hazards, be it turbulence, microburst, tornado, lightning, hail, icing, pressure and rain. Let me go through them with them one by one in bit of hurry. Turbulence, when it comes to say, I remember I told you, extremely hazardous, having the potential to cause overstressing of the aircraft or loss of control. Greatest turbulence occurs in the vicinity of rising and descending air, what we call as updraft and downdraft. Vertical currents may be strong enough to displace an aircraft up or down vertically as much as by 2,000 or 6,000 feet. Gust loads can be severe enough to stall an aircraft flying at a cruise speed in case of smaller aircraft and sometimes even in mid-sized aircraft. Maximum turbulence occurs near the mid-level of the thunderstorm cells between 12,000 feet and 20,000 feet. Heard about microburst? I'm sure you have heard about cloudburst. It is something similar. Unlike cloudburst where the rain water comes, it is the most violent form of downdraft. That means downpour of air only from a thunderstorm, an intense and localized descent of cool air causing a sudden outflow of horizontal winds above the ground. An aircraft flying through it may first encounter an increasing headwind and lift, followed by an increasing tailwind and sink completely. To overcome the adverse effect, the pilot needs to take timely corrective action to ensure aircraft safety. Let me give you some illustrations of landing as well as takeoff. Here is a takeoff initially appearing normal in case of microburst, wind shear encountered just after liftoff, and it came under the influence of microburst. Airspeed decreased, resulted in pitch altitude reduction. Further, what happened? Aircraft crashed off at the runway itself, departure end of runway 20 seconds after the liftoff. Actually, such kind of things have happened. I am not giving you some hypothetical examples. Next example, takeoff initially appeared normal, airspeed built up slowed due to wind shear, aircraft near end lifted off but failed to climb as much as it was required to do. As a result, there was hillock very close to the airfield Aircraft contacted obstacle of departure and crashed. Last example is about a landing. Approach, the final approach of the aircraft, what we call as glide slope. You can see the aircraft is positioned to land at the end of the runway here. Aircraft is here, and what happened? Approach initially appeared normal, but see this microburst, increasing downdraft and tailwind encountered by the aircraft at this stage. What happened? Airspeed decrease combined with reduced visual cues, resulting in pitch altitude reduction further. As a result, the aircraft couldn't even reach the end, beginning of the runway, and crash landed before that. Another aviation weather hazard associated with thunderstorm is lightning. As a thunder cloud moves over the surface of the earth, an electric charge equal to but opposite the charge of base of the thunder cloud is induced in the earth below the cloud. Induced ground change follows the movement of the cloud remaining underneath it. What happens? Lightning? Is it something small? No. Static electricity builds up in the airframe, interfering with the operation of radio, compass, and electric circuits. Lightning blindness affects the crew's vision as much as sometime for 30 seconds, making him not able to read the instrument. That means instrument reading becomes almost impossible. Probability of lightning strike generally is greatest in the range of minus 5 degrees Celsius to 5 degrees Celsius. If in close proximity of thunderstorm, lightning strike, ladies and gentlemen, can even happen through the aircraft when flying in the clear air. Here is an estimation. Interesting. Lightning stroke, you can take all the picture of this. How to estimate lightning stroke distance when it comes to the thunderstorm. What is lightning stroke and what is thunderstorm? Same thing. When lightning is at a much larger distance, it is known as lightning, and when it comes to closer, it is heard as thunderstorm. Hail, capable of inflicting serious damage to the aircraft, encountered at the levels between 3 km and 9 km, also encountered in clear air outside clouds as it is thrown upward and outward, especially active cells. Rain, per se. Heavy rain showers encountered during approach and landing can reduce visibility and can cause retraction on the windscreen of the aircraft, producing an illusion that the runway threshold is lower than it actually is. Water lying on the runway can cause hydroplaning, which destroys the braking action of the aircraft needed to bring the aircraft to a stop within the confines of the airport runway. Numerous examples. Drizzle, another form of precipitation per se, restricts visibility to a greater degree because it falls in stable air, often accompanied by another set of phenomena: fog, haze, and smoke. Another associated hazard with thunderstorm is aircraft icing. It occurs when supercooled water droplets strike an aircraft at temperature below 0 degrees Celsius. Effect is disruption of the smooth laminar flow over the wings, causing a decrease in lift, increase in the stall speed. What is stall speed? At which aircraft can even overturn. Absolutely, ulta ho jayega. Increase in weight and drag, thus increasing the fuel consumption. This is an actual example of Arabian monsoon experiment, RMAX. Can you see this? Icing deposit on the windscreen. There are other aviation weather hazards. Dust storms, a large quantity of dust sand are raised from the group to higher levels, reducing the horizontal visibility to 1 kilometer or less. My friend Gagan Gupta ji was talking about my earlier colleague, Air Commodore Behel, somewhere in Jodhpur. We experienced this. We have a lot of sharings on this particular incident, what caused the storm and how eight aircraft flying in the air in the night were saved, courtesy timely weather warning. Clear turbulence caused by rapid irregular motion of the air. It brings about bumps or jolts, but does not normally influence the intended flight path. However, when severe, abrupt changes in the altitude of the aircraft may occur and the pilot may momentarily lose control of the aircraft per se. Mountain waves. Just look at this picture itself. You will have clear idea how mountain waves can result into the aviation weather hazard for the aircraft which is flying in the air. Wind shear is something similar turbulence but in extreme lower levels. is a sustained change lasting more than a few seconds in headwind or tailwind, resulting in changes in the lift of to the aircraft. A decreased lift will cause the aircraft to go below the intended flight path. A change of 15 knots or more in headwind or tailwind is considered significant wind shear, which may require timely corrective action by the pilot. Sea breach usually develops under the fine weather and light wind conditions. We also have some airfield in the country which are located very close to the coast, and they are affected. But one of the classical examples which you see at the Hong Kong International Airport, the onset of sea breach is typically characterized by winds turning westerly with prevailing easterly winds blowing in the background. Significant wind shear may develop along the runways. I'm talking about where sea breach and the background winds meet. This is the front where such kind of turbulence can come. Fog and cloud, I need not train your minds, the educated minds like you, what happens in fog and cloud. Obviously, the visibility reduction tremendously, resulting into such kind of situation. To summarize, there are three actors, when it comes to the flying per se. Weather flying can be described by the three corners of a triangle representing the three important actors. The first actor I call as weather, dynamic factor with countless variables. The second factor or the actor is the aircraft, unfortunately with fixed parameters, whether it's speed, thrust, etc., etc. And the third one, the human element, which actually need to modify, whether it is human element pilot, when it is a support staff, they need to modify the fixed elements to match the variables in weather conditions. What is this picture about? In order to evaluate the risk, when it comes to the risk per se in the conditions of aviation meteorology, the best bet of yours as a pilot, as a support staff, as an ATC officer, and as a meteorologist should be the precursor wheels. And when I say precursor wheels, they were coined by NASA, none other than NASA. A precursor is an individual wheel, out of them, a factor that precedes and indicates. Sometimes it gives you warning enough, or suggests that there is a likelihood of accident. Whether that factor could be physical incapacity, whether it could be poor judgment of all the stakeholders or individual stakeholders, aircraft deficiency itself, failure of technology at the last moment, but last but not the least, weather. So what I want to say, it is the alignment of these wheels, not the individual wheels, which will result into accidents or incidents. So the aim of this last slide to tell you is, it is not only the three actors, it is the people like you who are around the ambit of the aviation meteorology. Each one of us have to play an important role to see to it that these wheels are never ever aligned to cause accidents and incidents. Thank you. Jai Hind. I'm available for you on various platforms which are there on the slide. You can take a click. I would love to not only be with you during this session, but throughout your life, not only with respect to aviation meteorology, with respect to various causes which I work for from day-to-day basis, just giving back to the society. Thank you so much.
Great. Maja aa gaya. Yes, I am seeing an enthusiastic teacher as well in you. Yes. It's a great questions. Before I come to you, let me just give some clues to my viewers at this moment. Friends, you had an enthusiastic Air Force officer today here. I am receiving some questions from you, and some of those questions have already been answered during Dr. Mahajan's deliberations here. One which he has given indirectly is probably the same that one of you has asked the question that how come the aircraft when it lands, its rear wheels, इसके पिछले पहिए पहले रनवे पर लगते हैं, अगला पहिया बाद में लगता है. Dr. Mahajan, you had indirectly given this answer during your detailed photographs in microbursts. Look, Friends, if the aircraft lands through its front wheel, look at the directions of the wind and the winds at that point, then a torque will create, and that may result into an overturn of the aircraft.
Absolutely.
Stalling of the aircraft. This you have answered. You have answered many other questions in between. There are some questions which are asked by children. There are some questions which I have and Simran have. So first, ladies first, Simran.
Okay. First of all, thank you for those enlightened pieces of information that you have shared with us. And as you just mentioned in the beginning that weather forecasts and their predictions, they are not 100% accurate. So, but still most of the times what we see is they are accurate. It turns out to be correct for us. So, what are the different kinds of technologies that go behind predicting weather forecast?
So, when I say not accurate, I was referring to 100% accuracy, that it was never possible yesterday, it will never be possible today, and it will never be possible tomorrow also.
Yes.
The reason is the atmosphere is governed by variables.
Yes.
You know, and when it comes to variables, they are at much smaller scale that even human mind can perceive or even design them in numerical weather prediction models actually, right? So they're happening at such kind of small scales actually. As a result, the chaos, as a result, the complexity, which I tried to cover. As far as the technology is concerned, the satellites, the radars are playing a very important role in bridging the gap of the observations.
Yeah.
There was a time when I joined the organization, Indian Air Force, we were in primitive stage, right? Unlike our counterparts in civil, Indian Meteorological Department, they had a lot of gadgets actually, but we had very limited gadgets. From those times when the observational network was at the tune of about 300 to 500 kilometer, space, today we have graduated to much, better sense actually. Particularly the satellite has played a very important role in this whole thing. Radars have played a very important role, and the numerical weather prediction models to accurately predict the weather have played a very important role in this.
Of course.
So you are trying to have, we are trying to find the orders in the chaotic system.
Absolutely.
So doesn't the supercomputers, which now seems to have superseded by the hardware designs, so that we have the hardware designs, but we do not have the corresponding usability by the softwares at this moment. However, 10 years ago the situation was a little different. So how do you feel, Dr. Mahajan, that हमारी कोशिश साइंस के स्टूडेंट है, कोशिश है 90% से 95%, 98% और थोड़ा सा आगे कहाँ तक हम पहुँच जाएंगे, because the situation in computing has really reached to a state where we can say probably we are doing it co-processor. However, these are step by step, so by nanoseconds order. So how far you feel that one can within the second law of thermodynamics, of course.
So from the times of Lorentz, failed experiment somewhere in 1950s, and Richards took over, and when it comes to numerical weather prediction models which were done on those times, of supercomputers, you can't even think about what kind of supercomputers were there. As I said, in case of aviation and meteorology limits have been pushed by the aviation safety needs actually. Similarly, computing power has been pushed to the limits by the needs of the accurate weather forecasting. So
that's true.
It is as simple as that.
That's very simple, simple you told us. Simran, you continue.
Yes, and so young minds, youngsters, as we are the first country to have a lot of youth faces, they are so much interested in pursuing a good career in defense forces.
Yes.
So your suggestions with that, regard to that, I have another question as well. Apart from academic knowledge and the expertise with the task and the skills, what other qualities need to be exhibited by a defense personnel?
Oh, great question, I must say.
Generic one.
No, wonderful question, yes. I must say. So I go back to my years in Air Headquarters, Ministry of Defence, 2009 to 2012, where one of our prime objective was to fill the gap. There was shortage in the cadres of meteorological branch at that time, and I have been listening about this shortage for almost 20 years plus, from the time I joined Air Force. So the collective team effort was that we tried to bridge this gap. How did we do that? We tried to reach each and every university through the local flying stations of Air Force and educate the masses there, particularly with respect to aviation meteorology, right? What we did was the MSc students actually who are the minimum required for joining this kind of branch actually, we reached out to them and told them about this space. So one of the important component of that capsule which I used to deliver and my friends across this country used to deliver was about officer like qualities actually, right? What we call as do you have it in you? You must have seen these boards,
Yes.
somewhere in Army, Air Force, Navy. What exactly is it? Do you have it in you? Is it something specific? Yes. And what comes to my mind, first of all, is integrity. The sense of integrity, the robust integrity, the character of the personality of the person. The second factor which comes to my mind is empathy as a factor actually. And the third, and not the foremost, is the sense of excellence, the pursuit of excellence. If these three qualities are there in you, right? Integrity, empathy, and excellence, you will be seen as a potential candidate because you will have that passion, right? When it comes to required to join armed forces. It's armed forces, defense forces is a wonderful life. It's a wonderful career, but it is not a job. It is a way of life actually, right? So this is
Okay.
what we need. We see here.
Yes, I remember. I mean, you have triggered one experience with us when we were doing question answer session with the children with Bharat Ratna Professor C.N.R. Rao.
Yeah.
One young, keep it on. I will ask a question
Okay,
there.
okay.
I have a question there.
Yeah.
So, let me come up with this experience for the benefit of the same question which Simran you raised. That was the time when astronomy. Space is also again in fashion nowadays, but it is around 2016 also. Astronomy was in news, astrophysics was in news, so as the astronomers, because the MOM took place at around that time, Mangalyaan mission. The children asked C.N.R. Rao, "Sir, I want to become an astronaut. What should I study today?" And the child was class 8th student. Knowing C.N.R. well, we were little furious, but nevertheless C.N.R. managed. And then he said, "Young man, you just have good physics, good chemistry, good mathematics at this moment and some biology up till class 10th, and the best thing for you to become astronaut today is you forget becoming an astronaut today. Think it after you get some physics, some chemistry, some mathematics." I remember that last time also when we were having last time nearly a month ago, we were having A.K. Anil Kumar from ISRO.
Okay.
He is the man who was behind this propulsion and space missions of
Yeah, I know him.
yes, of Aditya L1. He is on job there. I am sure that I told him that he will be listening him to us today also. He also said the same thing as Dr. Mahajan said, that be on what you are.
Yes.
We want persons, we will trace you, we will take you, and then we'll get the things what we want from you. So they will train, for example, Anil was trained by ISRO itself. He did his PhD in space junk technologies at Indian Institute of Science. He did several courses at Indian Institute of Space Science and Technology, etc., etc. So same with this is just to add what you said.
Yeah.
I remember CNR at this point. Look at the slide number 11. Coming back to that slide, sir,
Yeah.
if you allow me, where you were discussing the mechanism of airlifting.
Yeah.
I am being a student of physics, and we physics teachers explain it through Bernoulli's principle normally. But aviation engineers in particular, we had Devabam Das from IIT Kanpur here, who works in the aerospace technologies, and they have designed several aircrafts at that point. So he said that it's not probably the Bernoulli's principle alone, but you also mentioned, you also brought from the Newtonian mechanics the same technology. So how to actually explain this airlift on the basis of the Newton's third law of motion or on the basis of the Bernoulli's principle, sir?
Yeah, so I again repeat what I said actually, right? Ultimately, the aerodynamics, when it comes to aviation industry is to lift the aircraft. That's the primary aim actually, and not only lift the aircraft, to keep it safe actually, right? And two forces, which are of prime importance is weight versus the lift, right?
Thrust.
Yeah, and the drag versus the thrust actually.
Oh,
Right. So I mean these four forces which act on the flight actually play a
Combined
very-
together. So it means the pressure changes equation together with the
Yeah, I mean it's a science perhaps which cannot be told, in
a single shot.
in single shot
So
answer, actually.
one has to drive,
Yeah.
another the second.
That is why I try to made it as simple as possible actually.
यस यस आई अभी और एक आसान सा साहब,
हाँ,
बिल्कुल बिल्कुल हम टूरिज्म पर लौटते हैं। आपने लद्दाख का जिक्र किया, बताया कि साहब एयर डेंसिटी गर्मियों में और जाड़ों में मौसम के टेम्परेचर के हिसाब से बदलती है। 70% आपने बताया लगभग गर्मियों में रहती है एयर डेंसिटी के हिसाब।
Not just गर्मियों में तो और कम हो जाती है।
अच्छा,
So normal, if you see, as we go up in the atmosphere actually, right? As we go up in the atmosphere, you will find the air density is going to reduce, obviously.
Yes.
Obviously, right? And there comes a stage when it comes to about 50%, say about 15 to 17,000 feet, or say even 18,000 feet. Recently, I went for a cycling expedition,
Oh, you are a cycler.
of 700 kilometer in Himalayan region, and when we were at about close to about 16,000 feet, we could feel that, right?
Yes.
The oxygen levels are very less actually.
So this is the right time to visit Ladakh.
yes,
As compared to the June or the
no, I think, but the problem is about the weather actually, right? The climate of that place is of such nature where it is going to be very cold.
But I think I have not been to Ladakh yet. But I have been hearing from the colleagues that the oxygen is a major problem, particularly those who are flying to Ladakh.
So that is how initial 2 days, you need to acclimatize actually.
Oh, I
Acclimatize in that kind of environment actually. Otherwise you will fall sick actually.
Don't fall sick.
Because suddenly you are going from higher pressure to lower pressure.
Lower pressure. So, sir, I have many other questions. I will take all these questions a little later too. Again, sir. So we are running short of time.
Yes,
Simran,
of course,
please
sir.
end up.
We have paucity of time, but still, sir, it was a wonderful session. It was wonderful having you here with us, and of course, it's our honor to have someone from Defence Forces discussing at length and providing us your time. Thanks a lot.
My pleasure that you called me to this national forum and I could speak to not only you guys, to entire nation. actually.
Yes,
Thank
yes,
you.
yes,
Of course.
yes.
Thanks a lot. Right.
Thank you so much, Dr. Gupta. Very quickly, I'll request you to please provide details of the 65th session or the episode that we are going to conduct.
So दोस्तों, अगला सेशन भी बड़ा इंटरेस्टिंग होने वाला है। मैंने बात की थी आपसे कि हमने दिल की सैर की, फेफड़ों की सैर की, न्यूक्लियस की बात की, न्यूक्लियर फ्यूजन की बात की, बैटरीज की बात की। मैं कई बार कहता हूँ, आज फिर से रिपीट कर रहा हूँ कि हो सकता है कि मैं अपने लाइफ टाइम में ऐसी बैटरीज देख सकूँ कि एक बार एक वाहन में लगा दी छोटी सी बैटरी हमने मोबाइल फ़ोन के साइज़ की, और वो कम से कम 2 लाख किलोमीटर 2.5 लाख किलोमीटर ड्राइव कर सके बिना किसी बैटरी की। दोज आर द काइंड ऑफ फ्यूजन बैटरीज। सो आई एम टॉकिंग अबाउट द इंडियाज न्यूक्लियर पावर प्रोग्राम, फ्रेंड्स। सो next session is due on 3rd of November 2023, when we are going to have BVS Shekhar from Nuclear Power Corporation of India Limited, Mumbai. So looking forward meeting you again on 3rd of November morning, 10 o'clock. Thank you.
And viewers, do mark this date, that is 3rd of November, where we are going to discuss about Indian nuclear power program. Thank you once again to both of you for connecting with us, and thank you to all the viewers for connecting with CIET and CRT for this particular live interactive session. It is the 64th episode. We are wrapping up here itself, but here is an important piece of information for all of you regarding the availability of NCRT textbooks. NCRT textbooks for the academic year 2023 to 2024, they are widely available all across the country. You may also purchase them directly from the different sales counters of NCRT. You can also place an order online for these particular textbooks, and also viewers, if you would like to download them in the PDF or the soft copy version, that's possible through different mediums flashing on your screens. For further information, please scroll and explore the website of NCRT. Thanking you once again. We are wrapping up this conversation, but stay connected with us, because right at 12 in the noon we have another program, that is Teaching Learning Interventions for Inclusive Classroom, where we try to raise awareness about inclusive classroom setup. Once again, mark the date. It is 3rd of November 2023. Stay connected. Keep watching eVidya channels. Take very good care of yourself. Namaskar.